This is a question on properties of sound, and you have to use the wave equation later on also. So for part A, describe what is meant by a frequency of 5.1 kilohertz. It means that the air particles, because this is sound wave, so air particles, you must mention air particles, vibrate to and fro, or you can say left to right, and it makes 5,100 complete vibrations or oscillations per second or per unit time. That's how you can describe. Now, in part B, describe the difference between compression and rarefaction. Talk about the pressure. So, compression is a region where the air pressure is higher than atmospheric pressure, and a rarefaction is a region where the air pressure is lower than atmospheric pressure. Now, for part 2, for C part 1, first identify like what I said in the previous video. It's always easier to identify the compression points. For example, this is a compression point because the neighboring particles are very close to it. So identify the compression points first, over here and also over here. And rarefaction, you are identifying a point where the neighboring particles are the furthest away from it. So this is a rarefaction point. We can also use the trick that I've shared. The rarefaction is always in the midpoint of two compressions. So this is the midpoint, and this is the midpoint of the two compressions. So that's C part 1. And measuring sound wave, you've done this before. Choose any compression to compression. You can choose this compression to this compression. You can choose this rarefaction to this rarefaction. It doesn't quite matter. You get the same answer. But because the printing might be different for different batches, or so your answer might not be exactly 6.3 cm. But as long as you know how to measure the wavelength, I think that's the most important part. So I say again, your answer might not be the same as mine because our printing on the paper might be scaled a little bit differently. So for C part 3, calculate the speed of sound in the air. That's where the wave equation comes in. So frequency is 5,100. Just be very careful of the kilo in kilohertz. So it's 5,100, not 5.1. Same thing goes, the units part, please just be careful. The wavelength, as we have figured out in the previous part, is for me is 6.3 cm. Yours might be a little bit different, but just take note that this is in cm. So therefore, please convert it to meters. I always use SI units in my calculation to avoid any units error. So this is in meters, and therefore you will get 320 meters per second, which is roughly the speed of sound in air. Now for part D, first thing I will note is that the frequency is now doubled. You look at the frequency here is 10.2 kilohertz. It was 5.1 kilohertz. So when your frequency doubles, the wavelength will be half. Alright, so because if you look at the wave equation, the speed is constant. And if you want to double your wavelength, to keep the speed constant, your frequency must half. So if your frequency doubles, your wavelength must half. So over here I wrote that the wavelength is half. So what is the implication when the wavelength is half on this kind of diagram? It means that the compression to compression distance will be half also. That's what I'm writing here. So basically, this arrow here will not be so long already. It will be half the distance. And within from X to Y, which is the same distance, or you will expect to see twice as many rarefaction as before. There's more cycles within X and Y.